All right, good morning, Algebra 2. We are actually moving on to something a little bit different today. So we are going to, first of all, erase those. I have no idea what happened there. I just opened a brand new page. But we are going to start solving systems of equations. So we will still actually be using Desmos I can show you that you can check your answers, but I'm actually going to require you to do these by hand as well. So we do have to go through the solving. Showing your work will absolutely be required. You cannot just plug these into Desmos and get an answer. So I won't require you to do all problems by hand, but I will require you to do these. So we are solving a system of equation. So this is review from Algebra 1. And we are going to solve systems of equations by elimination. All right, so in order to eliminate, those are things that we want to equal 0. So we are looking for opposites today. Opposites, or when things equal 0. That's what's going to make us happy. So I have a few examples I want to show you. So the first one is negative 10x plus 8y equals negative 20. And we have a positive 10x minus 9y equals 30. So whenever you have a systems of equations, you can combine equations, but it's only helpful if we can make one of the variables equal 0. Therefore, we can solve for 1. So if we look at this, we're looking for coefficients that are the same. So in this case, we both have a 10x. One's a positive and one's a negative. So in order for this to become 0, negative 10 and positive 10 become 0. We are going to add our columns. So negative 10 plus 10 is a 0. So then positive 8 plus a negative 9, which is like 8 minus 9, that's a negative 1y. And then negative 20 plus 30 gives us a positive 10. So we really don't have to look at that anymore. It eliminates. That's the whole point. So whenever we look at this, we can now just divide this by negative 1, and we get the answer of y being negative 10. That's the y value that goes in here. So now we have to find the other variable. And what we do is we will take this and plug it in. It doesn't matter which equation you choose. And I'm just going to choose this one, 10x minus 9. But now I know instead of a y, I know that value is negative 10, so I plug that in. So this is the y that I solved for, and that's equal to 30. So now I can just solve this equation. A negative 9 and a negative 10 gives me a plus 90 equals 30. I can subtract my 90 from both sides. And that gives me negative 60. And then my final step, to get x by itself, I divide and I get x is negative 6. So just like we did with Desmos, this is actually the point of intersection. So our solution, we can write as an ordered pair. X always goes first, y goes second. And if you wanted to plug this in on Desmos and look at the lines, that point of intersection would be negative 6, negative 10. All right, so I got a couple more for you. Next one here, we have negative 6x minus 10y equals negative 14. And then we have negative 6x minus 5y equals negative 19. All right, so when we are looking at this, we do not have opposites. We have the same coefficient on our x's. They are both negative 6x. In order for it to be a 0, we need to subtract these. So if you subtract each one of these, if you subtract a negative, it essentially turns it into a positive. So whenever I solve this, I'm not changing the top equation at all. But in order to get these, we want these to eliminate. We have to subtract. So 2 negatives here would give me a positive 6x. A negative and a negative here would give me a positive 5y. And a negative and a negative 19 would give me a positive 19. So now these are officially opposites, so they become 0. So now I can combine what's left. Negative 10 plus 5 is a negative 5y. Negative 14 plus 19 is a positive 5. So we divide by a negative 5 and we get y is negative 1. So then if we want to go back to one of the original equations, again, it doesn't matter if you choose top or bottom. I'm just going to use the top one. Now, instead of y, I now know that's negative 1 because I'm taking that value and I'm plugging it in to that original top equation. And so now I can just solve it. Negative 6x plus 10, because 2 negatives make a positive, equals 14. Subtract my 10 and I get negative 24. And I divide by negative 6 and I get a positive 4. So my solution, x is 4, y is negative 1. And if we wanted to do that on Desmos, that would be our line of intersection. All right, I've got a couple more. All right, do we see anything that makes 0? All right, a negative 4, and that's a 1. We just never write it. That doesn't make 0. But what about a positive 5 and a negative 5? Absolutely makes 0. So we are ready to combine. We get negative 3x equals 5 minus 20 is negative 15. So we divide by negative 3, and we get x is 5. So we know our x coordinate. So now I'm going to take this original x minus 5y equals negative 20, but I now know x is 5. So then I can subtract my 5, and I get negative 5y equals negative 25. And I divide 2 negatives are going to give me a positive 5. So both x and y are 5, so my ordered pair for my point of intersection is 5, 5. All right, and our final example for today, we have negative 6x plus 9y equals negative 9. Then we have negative 10x plus 9y equals 27. Okay, 10 and 6 on the x's definitely are not opposites. But here, right now, if we add those, that's 18. We want this one of those to be we need to subtract in order to get these to eliminate. So the top equation doesn't change. But on the bottom, if you multiply 2 negatives, it becomes a positive 10x. Subtracting a positive is a negative 9y, and then that gives me a negative 27. So when you're subtracting, you're essentially changing all of these signs to the opposite. And whenever we do that, they eliminate. And so now we can take negative 6 plus 10, because that's positive. So that'd be 4x. And then this becomes negative 36. So we divide by 4, and I get x is negative 9. So then I can pick top or bottom, and I'm going to go with the top equation because it's smaller numbers. But I now know x is negative 9. And so that becomes a positive 54 because it's 2 negatives. and then I subtract 54, and that becomes negative 63. Divide by 9, and I get y is negative 7. So then my ordered pair would be negative 9, negative 7 for, if I were to graph those two lines, I would see that as my point of intersection. So this is what we're going to be doing for the next few days. Obviously, our examples are going to get a little bit more complex, and we're going to do some real life stuff. But you guys, at this point, do not have homework for this evening, but you guys will be doing some work tomorrow for an in-class assignment. Virtual kids, I will give you more instructions on that. But I hope you guys all have a great day, and if you have questions, don't hesitate to ask.